I'm in Santa Clara, California, outside Intel's headquarters. It's what you'd call a liberated building. There's a Wi-Fi signal on every floor. You don't have to stay in your office to get onto the network. The trouble is when you go outside. Here we are in the parking lot, and in fact I can still get a signal. It's a secure network, so I can't hack in. But let's see what happens if I walk a little bit further away. I've now walked to the far side of the parking lot, and I guess I'm about 500 feet from the building. And there it is, I've lost the signal. The problem is, how do you get those kind of broadband wireless speeds out to a large area like this, where many places can't even get DSL? Now, we'd love to get fiber out to every home, but to do that, you have to dig a trench. That costs as much as $300 per foot through a busy area. To go 10 miles could cost you as much as $15 million. There has to be another way. Here's what's now emerging as the solution. This looks like a normal Wi-Fi access point. Actually, this from Aperto Networks is an early version of the big brother to Wi-Fi, WiMAX. WiMAX is designed to send a signal a much greater distance at even faster speeds than Wi-Fi. So we're going to take a look at how well this works, and to do it we're going to take a video signal, compress it through this PC and send it video over IP and see how far away we can pick up that signal. I'm on a balcony on a house on the far side of San Jose, and my GPS locator here is telling me that I'm 10.2 miles from that WiMAX access point, and I'm still getting a good signal. Robert, could you give me a wave?
How about that?
And that's showing I'm getting about 6 megabits per second or thereabouts over a distance of 10 miles. Now that gives us a radius of enormous coverage, of course, several hundred kilometers. This technology is still in its early days, and we're going to see a lot of improvements in the next 2 years. WiMAX is a global standard, and that means that companies all over the world are going to be working and improving on the equipment. Right now, we have a line-of-sight antenna to get this kind of performance. Over the next couple of years, you're going to see equipment that can be installed inside the home without an external antenna. The result is that WiMAX is going to be able to connect up a lot of places that can't get high-speed internet access. And it's going to give an alternative to current technologies like DSL. Homes, buildings, schools, hospitals all have a new way now of getting new high-speed broadband internet access through wireless. We've driven our van here literally to the end of the road in the hills above San Jose, and the GPS locator is telling me we're now 12.2 miles from the WiMAX transmitter on the top of the Intel building. We're still getting a great signal, 7 megabits in one direction, 1.5 megabits in the other direction. I said earlier on that you're going to see the benefits of WiMAX in urban areas, extending DSL cable or fiber and reaching other areas that can't be accessed. But really, this is also the technology that's going to reach the next 5 billion people. Realistically, there's something in the range of 5 billion people that will not be able to get onto the internet via copper or via fiber. This is the way they're going to get access to that technology.